All right, so you sent over some research about this new tool called VulDeeLocator.
Mm-hmm.
And it's supposed to be this like super powerful detective for finding software vulnerabilities.
Right.
It's kind of feels like we're about to step into a digital crime scene, swapping out fingerprints for lines of code.
Yeah, you got it.
So this paper claims that VulDeeLocator uses deep learning to not only like spot those vulnerabilities, but it can tell you exactly where they are in the code.
Exactly.
So it's not just pointing at a messy room and saying, "Hey, there's a problem in here." It's saying, "Hey, the problem's under that floorboard."
Yeah,
That could be a game changer.
for sure.
Especially with more and more vulnerabilities popping up all the time.
Exactly. We're seeing a constant rise in like the number of vulnerabilities that are reported in the CVE database.
Right.
It's really becoming mission critical to find these weaknesses, before somebody with bad intentions does.
Okay, so let's talk about how people are trying to find these vulnerabilities now.
Sure.
What's the current state of the art?
So we have some automated methods, but they're definitely limited.
Okay.
One approach is like like facial recognition, but for code. It spots sections of code that are nearly identical,
Okay.
and it figures if one piece is bad, the others probably are too.
Right.
It's good at catching copy-paste errors, but misses the more subtle stuff.
Right, like finding the same typo in multiple emails.
Exactly.
Helpful, but doesn't catch those deeper grammatical errors.
Right. Then there's the rule-based approach,
Okay.
where experts set up these specific patterns that signal a potential vulnerability.
Gotcha.
Problem is those rules are often very rigid.
Mm-hmm.
They miss those complex cases,
Right.
and they generate a lot of false alarms.
Right.
So it's hard to separate the real threats from the noise.
So too many false positives and false negatives.
Exactly.
What about using deep learning?
Yeah.
It seems like that's becoming kind of the go-to solution for these kinds of problems.
Absolutely. Deep learning has huge potential. It can sift through mountains of data, learn these really complex patterns.
Mm-hmm.
But there have been some earlier attempts to use it for vulnerability detection, like VulDeeLocator and Sysavia.
Okay.
And they've had their limitations.
Like what were they missing?
Well, they struggled to really grasp the true meaning of the code, what we call that semantic understanding.
Right.
So it's like knowing there's a problem somewhere in a book, but not knowing which chapter to focus on.
Okay.
Or even which paragraph.
So VulDeeLocator is trying to solve that.
That's right.
Give us the rundown of how it works.
Okay, so VulDeeLocator combines the strengths of classic program analysis
Okay.
with the power of deep learning.
So it's like Sherlock Holmes teaming up with a supercomputer.
You could say that, yeah.
Uh-huh.
So the first step is like a detective doing some initial legwork.
Okay.
Analyzing the code, it flags suspicious snippets based on these known vulnerability patterns.
Okay.
These patterns are things like, how library functions are called? How arrays and pointers are defined,
Gotcha.
and certain types of arithmetic expressions.
Okay, so it's looking for specific red flags in the code that often lead to trouble.
Exactly.
What happens next?
Well, this is where things get really interesting.
Okay.
So instead of just looking at the raw source code, VulDeeLocator translates it into something called intermediate code,
Okay, hold on.
specifically using a framework called LLVM-IR.
Intermediate code. What is that, and why go through the trouble of translating?
Okay, so think of it like this.
Okay.
You have a complex blueprint for a building
Mm-hmm.
with all sorts of lines and symbols.
Right.
Intermediate code is kind of like taking that blueprint and redrawing it in a cleaner, more organized way, making it much easier to spot those structural weaknesses.
So it's not about changing the building's design.
Right.
It's about making the design easier to understand and analyze.
Precisely. And because intermediate code represents the program's logic in its standardized form, the deep learning model can really dig in. Understand the relationships between different parts of the code. For example, intermediate code uses a structure called static single assignment form,
Okay.
where each variable is defined only once.
Right.
This makes it much easier to track how data flows through the program, revealing vulnerabilities that might be totally hidden in that original source code.
Okay, I'm starting to see why this could be so powerful.
Yeah.
But I have to ask, how does it actually pinpoint the exact line or lines of code that are causing the problem?
Okay, so they've got this specialized neural network for that called BRNN-VDL,
Okay.
which stands for Bidirectional Recurrent Neural Network for vulnerability detection and locating.
All right, I'm going to need you to break that down a bit.
Sure.
What's so special about a bidirectional recurrent neural network?
Imagine you're reading a sentence.
Okay.
To fully understand it, You need to consider not just the words themselves, but also the words that come before and after.
Right.
BRNNs work the same way.
Uh-huh.
They analyze code both forward and backward, picking up on those subtle relationships and dependencies between different parts of the program.
So it's considering the full context of the code, not just isolated snippets.
Exactly.
And what about that VDL part?
Right. So that's where the real magic happens.
Okay.
It's like giving our code detective a magnifying glass and a laser pointer.
Right.
BRNN VDL adds these extra layers to the neural network that help it focus its attention on the most suspicious lines of code, narrowing down the search and dramatically reducing those false positives.
So it's not just blindly analyzing everything, it's intelligently prioritizing the most likely culprits.
Exactly.
And slick. But does this actually work in the real world?
Right.
Can VulDeeLocator really find vulnerabilities that other methods miss?
That's what we'll be diving into next.
Okay.
The researchers put VulDeeLocator through a battery of tests, comparing it to other techniques on both synthetic and real-world code.
Okay.
And the results are pretty remarkable.
All right, I'm hooked. Let's take a closer look at those results.
So they found that VulDeeLocator consistently outperformed those other methods. Like it achieved a much higher F1 score.
Okay.
Which is, a measure of how well it balances accuracy with catching all the actual vulnerabilities.
So it's not just finding a bunch of problems, it's finding the right problems.
Right.
That's what we want.
And when they looked at how precisely it located the vulnerabilities, it blew the other deep learning approaches out of the water.
Okay.
Achieving a 4.2 times improvement over Cybersecurity.
Wow. They
use a metric called IOU, which measures how accurately the tool pinpoints the exact section of code that's vulnerable.
A 4-fold improvement. That's huge.
Yeah.
Did they test it on real software, or was this all done in a lab setting?
They tested on real-world programs like FFmpeg, Wireshark, and Libov.
Okay.
Not only did it successfully detect known vulnerabilities, it even found 2 brand new ones that had gone unreported.
Really?
Yeah, these were later silently patched by the developers.
Wow.
So showing the real-world impact of this tool.
That's amazing. It really seems like this could be a game changer for making our software more secure.
It definitely has the potential.
Yeah.
But it's important to remember that it's not a silver bullet.
Right.
There are still some limitations.
Like what are the things they still need to work on?
Well, one limitation is that it's primarily focused on C code right now.
Okay.
This is partly because of the availability of tools and the maturity of the LLVM IR framework we talked about earlier.
Right.
But the reality is that most software today is written in a mix of languages.
Yeah.
Each with its own, quirks and challenges.
So adapting it to other languages won't be a simple copy-paste job.
No. It will require a lot of careful thought and research. Each programming language has its own way of expressing things.
Right.
Its own syntax and semantics, and different types of vulnerabilities are more common in different languages.
Yeah.
Plus, some languages aren't even compiled into intermediate code like C is.
Right.
Which would require entirely new techniques for analysis.
So expanding VulDeeLocator's capabilities to cover more programming languages is a big task, but it would have a huge payoff.
Yeah, for sure.
In terms of making more software secure, one thing that struck me about this research is that they actually did a user study with real people. They didn't just rely on the technical metrics.
That's a really important point.
Yeah.
In the end, these tools are meant to be used by humans.
Right.
So it's essential to understand how well they work from a human perspective.
It's like it doesn't matter if a car can go 200 miles per hour if the driver can't control it.
Exactly. So they had computer science students evaluate the output of VulDeeLocator and compare it to SysAvar, that other deep learning-based detector.
Okay.
They wanted to know, how easy it was to understand the vulnerability from the tool's output, located in the code.
Right.
Explain why it was a problem and figure out how to fix it.
So they were looking at whether this could actually help security professionals do their jobs better and faster?
Yeah, exactly.
What did they find?
Well, the students consistently rated VulDeeLocator higher than Cybersecurity on all those criteria.
Okay.
They found it more concise-focused and easier to understand. And the fact that it pinpoints the vulnerability down to just a few lines of code instead of dozens or even hundreds makes a huge difference in terms of actually fixing the problem.
That makes sense. Nobody wants to be stuck searching through a haystack when they have a fire to put out.
Exactly.
Yeah.
This user study really underscores the importance of human-centered design. Even in something as technical as cybersecurity,
Yeah.
it's not enough to just build powerful algorithms.
Right.
You have to build tools that empower humans to make better security decisions.
Speaking of making a difference, let's go back to those real-world program files they tested.
Okay.
Finding 2 completely new vulnerabilities in widely used software is pretty impressive.
It really highlights the potential of VulDeeLocator to find those hidden weaknesses that other methods miss. It's not just a theoretical concept. It's a tool that can have a real impact on the security of the software we use every day.
And it's not just about the number of vulnerabilities it finds.
Right.
It's also about the quality of the information it provides, right?
Exactly.
You mentioned earlier that VulDeeLocator pinpointed the vulnerabilities to an average of just 3.8 lines of code,
Yeah.
compared to over 76 lines for CySFR.
That level of precision is crucial.
Right.
It drastically reduces the time and effort required to understand and fix a vulnerability.
Yeah.
Imagine having to sift through hundreds of lines of code just to find the one tiny error versus having the tool tell you exactly where to look.
It's like the difference between getting vague directions and having GPS navigation.
Right, and this is just the beginning. As deep learning techniques continue to advance and as we learn more about the nature of software vulnerabilities,
Yeah.
I expect we'll see even more powerful and sophisticated tools emerge.
I'm excited to see where this goes. It feels like we're on the verge of a real breakthrough in how we approach cybersecurity. But I think we've given our listeners a lot to think about already. What do you say we wrap up this deep dive with a final thought?
Sounds good to me.
Okay, so we've really dug into like the nuts and bolts of how VulDeeLocator works. We've seen its impact on like real-world software.
Yeah.
And even kind of glimpsed how it might like change the future of software development.
Right.
But before we wrap up, I think it's worth like taking a step back and kind of looking at the bigger picture here.
Absolutely. What does the emergence of a tool like this, tell us about the direction cybersecurity is heading in?
Yeah. What new questions does it raise?
For one, it highlights the growing role of artificial intelligence in cybersecurity. We're seeing AI being used everywhere from, spotting threats and stopping them to responding to incidents and even in ethical hacking.
Right. It's like AI is everywhere these days.
And that trend is only going to accelerate.
Yeah.
The volume and sophistication of cyber attacks are increasing so rapidly that like humans alone won't be able to keep up. We need these intelligent systems that can learn, adapt, and respond to threats at a speed we simply can't match.
But more power means more responsibility, right?
You're absolutely right. AI is a tool. And like any tool, it can be used for good or for bad.
Yeah.
We need to be incredibly careful about how we develop and deploy these systems, making sure they're used responsibly and transparently.
VulDeeLocator also kind of raises some interesting questions, I think, about the future of software development. If we have these tools that can like automatically find and even fix vulnerabilities,
right,
does that mean like human developers will become obsolete?
I don't think so at all.
Okay.
In fact, I think it could free up developers to focus on more creative and strategic work.
Yeah.
So instead of spending countless hours hunting down bugs, they can focus on designing innovative features, improving user experience, and building more robust and resilient systems.
So it's not about replacing human developers. It's about like augmenting their abilities and letting them do what they do best.
Exactly. It's a collaboration between human ingenuity and artificial intelligence.
Right.
Each playing to their strengths to achieve a shared goal, building a safer and more secure digital world.
That brings us to our final thought for this deep dive.
Okay.
We've covered a lot of technical ground today, but ultimately the success of any cybersecurity effort hinges on one crucial element: collaboration.
I couldn't agree more. Cybersecurity isn't a solo mission.
Right.
It requires individuals, organizations, and even governments to work together and share information.
Tools like VulDeeLocator can be a powerful force for enabling that collaboration, providing a shared language and platform for understanding and addressing vulnerabilities. But it's ultimately up to us as humans to build the trust, the relationships, and that shared sense of responsibility needed to create a truly secure digital world.
Well said. So as we venture further into the world of cybersecurity, let's remember that technology alone won't get us there. It's the human spirit of collaboration, innovation, and a relentless pursuit of a safer digital future that will ultimately lead to success.
And on that note, we want to thank you for joining us on this deep dive into the cutting edge of vulnerability detection. We hope you found it insightful and maybe even a little bit inspiring. Until next time, stay curious, stay informed, and stay secure.